Hello, in this video we're going to look at some higher order derivatives. So we're going to find the third and fourth derivative of these functions. So our first example, we have f of x equals the quotient x minus 4 over x minus 6. And so in order to find the third and fourth derivatives, we have to find the first and second derivatives too. So let's first find our first derivative. This is a quotient, so we are going to have to use a quotient rule. So our bottom times the derivative of the top, the derivative of x minus 4 is 1, minus the top times the derivative of the bottom, the derivative of x minus 6 is 1, all over the bottom squared. And multiplying by 1 doesn't do anything, so let's go ahead and distribute that negative in the numerator. So we'll get a minus x and a plus 4. And so that numerator is going to simplify. Those x's are going to add to 0, and so we're just going to be left with a negative 2. And this one, I'm actually going to go ahead and write it as a product here, negative 2 times x minus 6 to the negative 2. Because that negative 2 is a constant, this will make taking our upper derivatives a little bit easier. So our second derivative, this is just a chain rule problem now. So we have negative 2 times the derivative of x minus 6 to the negative 2 is negative 2 times x minus 6 to the negative 3. And then technically we've got to multiply by the derivative of the inside there, which is 1. And so that's going to just simplify to 4 times x minus 6 to the negative 3. And I'm not going to completely simplify this and write that back in the denominator yet, mainly because 1, this isn't our answer, but 2, it makes taking the third derivative easier. So our third derivative, f triple prime of x, we're going to do the same approach. And so we're going to have 4 times that exponent of negative 3 is going to give us negative 12 times x minus 6 to the power minus 1. So we'll get a new power of x minus 6 to the negative 4. And then again, we need to multiply by the derivative of the inside, but that derivative is just 1. And so if we clean that up, we get negative 12 over x minus 4 to the 4th. So that is our third derivative in its simplified form. But in order to take our fourth derivative, and the fourth derivative is a little bit different notation, we'll stick with f prime, f double prime, and then sometimes you'll see f triple prime, sometimes you'll go ahead and see people write it with that 3 in the exponent. That just means when you put it in parentheses in that exponent there, what that means is the third derivative. You might also see Roman numerals. Typically the Roman numerals you'll see for 4 or 5, but more common you'll see that number in parentheses in the exponent. But to take this, we are going to go ahead and look at the derivative before we simplified it. So we're going to be looking at this form of the derivative to take that fourth derivative. Same way we've taken the second and the third, we're going to get negative 12 times negative 4 is going to be a positive 48 times that x minus 6 to the negative 5th. And then again, technically we've got multiplied by 1 for our derivative of that inside, but of course multiplying by 1 doesn't do anything, and so we get that our fourth derivative simplifies to 48 over x minus 6 to the 5th. I don't know why that became a 2. That should be a 5. All right, let's look at another example. Same thing, we want to find the third and fourth derivative. This time our function is e to the 4x. So again, this is a chain rule problem. We've got to start out finding the first derivative, and so the derivative of e to the 4x is going to be e to the 4x times 4, or if you want to write that, 4 times e to the 4x. Our second derivative, we're going to do the same type of thing. In fact, it's going to be the same thing, we're just going to multiply it by another 4. And so we're going to end up with 16 times e to the 4th, because the derivative of e to the 4x is 4 times e to the 4x, but then we also need to multiply it by that 4 that we had from our first derivative, so that's where that 16 came from. And then taking our third derivative, just going to repeat that same process again. Now we're going to have 16 times the derivative of the exponent, and so that's going to be 64 e to the 4x. And then our fourth derivative of x is again multiplying that by 4, which is 256 e to the 4x. All right, I'll see you guys next time.